Welcome to another episode of PEEPanEIP, an EIP dedicated series where we discuss an Ethereum improvement proposal and understand how it is going to make Ethereum even better. I'm your host, Pooja Ranjan. Before we proceed with today's discussion, a quick reminder. If you have missed discussion of any other proposal that we have covered in earlier episodes, you may follow the recording available on PEEPanEIP playlist at Ethereum Catastrophe YouTube. Today, we are going to talk about a beacon chain proposal that helps prevent validator slashing in certain cases. EIP-3076 validator client interchange format is a core proposal that is already implemented in 4 clients: Lighthouse, Nimbus, Prysm, and Taku. Created in September 2020, the proposal is in draft status. To provide an overview of the proposal, we have got the co-authors of the proposal, Michael and Sacha, from Lighthouse and Nimbus, respectively. We have also got Brent Alsop, Alita from the Cat Herders team. Welcome to the show. Glad to have this chance to talk to you all. Let's start sharing a brief introduction and association with Ethereum, followed by the presentation, and then we have got a few questions for you. Let's start with Michael.
Cool. Thank you, Pooja. So my name is Michael Sproul. I work on the Lighthouse client at Sigma Prime. I first got involved with Ethereum maybe almost 2 years ago when I saw a job ad on Twitter and I thought, okay, writing a decentralized blockchain in Rust in Australia, which is where I live, that sounds ideal. So I joined up, and since then I've worked on lots of things in the Lighthouse client, including slashing protection, the database, the consensus layer, things like this. And I came to write this EIP, or what became this EIP, one morning when someone said, oh, we need a standard format for these validators. Yeah, over to you, Sacha.
Hi, so I got involved thanks to Barnaby, actually, who's now at the Ethereum Foundation, but at the time he wasn't. And I was researching climate change, and I wrote a sort of visual article sort of going into, from first principles, it was mainly trying to answer questions for myself, trying to really understand from first principles what was going wrong and what we could do about it. And he read it and he really enjoyed it and sent me a message. And then I don't know if it was at the same time, and maybe I got the order wrong, but I also discovered that he was doing visual articles on Casper CBC. And so we kind of bonded over that, over sort of this visual essay format. And we started working on visual explorative essays around blockchain research. And the short of the long of it, or the long of the short of it, I can never remember which way, is that Danny was looking for a technical writer for Ethereum, and Barnaby recommended me, and that's how I got started. And from there I helped out. I did a bit of the early Lighthouse docs and also Nimbus, and then Nimbus lost their technical writer, and because I'd already known the team, I kind of slotted in quite naturally there. And so I'm mainly doing Nimbus stuff now, but also EF stuff as well when Danny needs help with writing something. Yeah, my involvement in the IP, I mean, to be clear, this is Michael's brainchild. I just sort of kind of helped write it and make things clear, but it's all him. And you know, some back and forth in the conversation with Danny and so on, but it's mainly Michael.
Thank you so much for your introduction. Let's move on to the overview of the proposal.
Okay, so this is me, right? I'm starting. Okay, got it. So this is the validator client interchange format. Okay, next, I guess. Okay, so essentially the the worst thing that can happen to you as an individual when you're running a validator or node is getting slashed, right? First of all, you lose a not insignificant amount of ETH, and secondly, it's game over. You can't really you can't validate again with that same validator, right? You have to deposit a whole new 32 ETH and so on. So this is the thing you really want to avoid as much as possible. So it makes sense to have to try and make it as hard as possible for users to shoot themselves in the foot. And the goal of this EIP is to get us some of the way there. And it's also to make it easy for people to switch between clients. So once you have these sort of checks in place, you need to standardize it in a way that if you want to move your validator from one machine to another or from one client to another, you can do it in a way that's compatible, that doesn't require you to think too much. Okay, next. Oh, so I kind of did this a little bit already. Yeah, so the motivation essentially, maybe I'm repeating myself a bit, but every client has a slashing protection database, and if you standardize it, you make it easier for people to switch between clients. And that can also be useful if one client goes down because of a bug, right? There's then you don't want to be sitting on the sidelines doing nothing. You want to maximize your returns, so you want to switch to another client. But if there's a risk you'll be slashed because you'll contradict yourself, then you might not do that. So this is to make it as easy as possible. If you have a standard across all clients, then it's very easy for someone to if something goes wrong with their client, to move to another one. So that's the background. Yeah, so to get into the details a little bit, slashings are when you make you kind of you're slashed for things that essentially well, I guess there are two ways this validator can be slashed: what's called double voting and surround voting. And I think Michael's actually done some amazing graphics that go into that. So maybe we can go.
Yeah, we can do that. Yeah.
Okay, so here, double voting is when you're sort of voting for two blocks in the same epoch. So you see here that the target epochs are a validator here is voting for two different target epochs. It's kind of the equivalent of a double spend. Is that correct, Michael? Is that how you would describe it?
It's kind of, yeah. These are, I intended this diagram to be an attestation though. So yeah, it's an attestation with a source in epoch 560 and then two different targets in epoch 561. So it's kind of saying that you're voting on two blocks, but those blocks conflict. So they could be, if there were transactions, they could be double spending in those two transactions, and you're voting on the validity of both of them with a double vote.
Right. And so clearly you can't allow that, because otherwise you have two versions of the truth out there. So that's probably the is that the most frequent cause of slashings? Do we know?
Yeah. It definitely is. I think almost all the slashings we've seen on mainnet have been double votes, and there were a whole spate of them yesterday, actually. So this presentation is quite well timed.
Yeah. So that is the most common one. So this, I think, and Michael, correct me if I'm wrong. Here you're showing that this is also, although it looks quite different, this is also a double vote, because essentially you're voting for a different target here.
Yeah. And this is actually one of the main ones that we see on mainnet, because this corresponds to, you're still voting for two things in that target epoch of 561, But the reason you might accidentally make a vote like this is if you had a node that was out of sync. So your out of sync node thinks that the source is 559 and you vote to 561. And then when you catch up again, you vote from 560 to 561 and you've double voted and it's game over.
Right. And the other way you can be slashed is called surround voting, and that's essentially when you're voting for one version of reality and later voting for another in a way that doesn't make it clear that you no longer believe in the first. But here the specific conditions are that you have two source and target epochs, and the source and target of one of them have to be surrounded by the source and target of the other. That's why it's called the surround vote. Michael, do you have some intuition as to that way to describe it intuitively?
Yeah. So this one is kind of hard to explain, but like there's no reason that you would ever do this as an honest validator, because with your first vote at the top here, you're saying that the current epoch is at least 562, and the justified epoch is 559. So you're making a vote from saying, okay, 559 is justified and I want to vote for 562. And then if you later make the small vote at the bottom there, you're saying that time went backwards from 562 to 561, which doesn't make any sense, and that 560 is now justified. So you're acknowledging the progression of time on one side, but not on the other. So it's kind of, it's all over the place. And the consensus proofs for Casper FFG require that this case be prevented, because you can essentially trick the network if you're allowed to make votes like this. Yeah. Okay, cool. I think I'll start presenting now about the specification that we came up with for the interchange format. So the specification itself is a JSON file. It allows you to export multiple, the history for multiple validator pub keys in each file. So you don't need multiple files for different validators if you have them all in one bundle. And you can have a list of blocks and attestations that you've signed for all your validators. And then perhaps most importantly, there are some rules about how to interpret this import file if you import it into a new client. This is an example of the format that we came up with. There's some metadata at the beginning that just includes a version for sort of backwards compatibility considerations, and a Genesis validators route, which is just to kind of pin it to one specific beacon chain. And then there's the data where you have a pub key, a list of blocks that you've signed, and a list of attestations that you've signed. And yeah, we can return to this example if people have questions, but I'm going to keep going for now. So these are there's 5 signing rules. These are the signing rules. Probably the most intuitive ones are number 1 and number 3, which just say that if there's a block or an attestation in the validator interchange file that you imported, then your new client that you're importing to should never sign anything that is slashable with respect to those messages that you've imported. So the only slashing offenses you can commit for blocks are double votes. So no double voting on any slot from the blocks that you imported, and no making surrounding attestations for any attestation from the set. And then the other rules 2, 4, and 5 are about not making messages prior to the portion of history that you imported. So if you have a partial history from, say, slot 1000 forwards, rules 2, 4, and 5 ensure that you don't start going back before slot 1000 and making attestations that begin there and end anywhere, and that you don't sign any blocks prior to slot 1000, and that you don't, if you have a separate minimum attestation target, that you don't also make anything less than that target, any target votes, because that would be, it's equivalent basically to time going backwards. And there's a caveat here in that we use the minimum rather than the maximum, and there's a good reason for that I'll get to in a moment. Yeah, so the reason that we design the format like this in a maybe slightly surprising way with that minimum rule is partly to support a diversity of implementation. So there's various ways that clients implement slashing protection databases, and we want to be compatible with all of them. And we also want it to be flexible enough to handle catastrophic outages. And in fact, the spec was born out of an outage on the Madasha testnet where it would have been very useful to have a format like this. So firstly, just about implementation diversity. There's two main schools of thought when it comes to how to make a slashing protection database. One is a complete history model in which you keep a copy of every message that your validator signs. And this ends up being, you keep more data than in the minimal approach, which I'm about to cover, but it ends up being a fairly straightforward way of keeping track of what your validator has voted for. In the minimal approach, you only need to keep the latest message. So you keep the block that you've signed with the highest slot, or the slot of the most recent block that you've signed, and also the source and target of the most recent attestation that you've signed. And this is the approach that Teku uses. And it has a lot of advantages because it's very simple. The one thing that it can't do, though, is if you accidentally vote really far in the future, then you're definitely blocked to that point in the future. And that's actually related to the outage that we saw. So yeah, those minimum bound rules that we saw before, the 2, 4, and 5, I can go back and show you them actually just to be. So we're saying no attestations with source less than the minimum imported source. So if you have an attestation with source 5, nothing with source less than that. And no attestations with target less than or equal to the minimum imported target. So these rules use the minimum so that if someone signs something far in the future that's completely unrelated to the rest of their attestations, you can keep signing in the gap in between. Whereas if a client like Teku that uses the minimal format exports to the standard format, then they're only going to export one block and attestation, and it will be the latest block and attestation. And we will also not sign before that, which is equivalent to Teku's slashing protection. So it's, in this case, when you only have one block, the minimum block is the same as the maximum block, and Teku just say, here's our latest block, don't sign anything before that. And we go, okay, that's good, we can do that. And the other clients understand this and implement this as a sort of low watermark, where you advance this low watermark each time you import one of these interchange files. So maybe this would be a good time to take questions. Does anyone have any questions about that mechanism?
So I have, because I know you later mentioned that for certain types of clients, you should take the highest block, and then others you should take the minimum. And if they're sending you multiple blocks that are like, I mean, you have multiple like epochs or whatever, wouldn't that be an issue because they're kind of like giving you the future or whatever? Or is that not how that works?
So the intention here is that if you have an interchange file, it should represent an uninterrupted view of the validator's behavior in that period of time. So if the file contains a whole bunch of blocks and attestations from some starting point to an end point, we assume that that's everything that happened between those 2 points. So although we could enforce a rule that says don't sign anything less than the maximum, we weaken that slightly to say don't sign anything less than the minimum. And that's in order to deal with this case where someone has accidentally signed something far in the future. So actually, I'm going to get that. I'll get to that on the next slide. Maybe I can go to the next slide and it will make more sense. So during this, I think there were 2 main outages on the Madasha testnet. The first one happened when there was a clock sync bug in Prysm that caused a whole bunch of nodes to sign an attestation really far in the future. And they also signed blocks really far in the future as well. And I think forget that. So if you do have this big gap, it's like you've got attestations happening every epoch, and then you've got one that sort of leaps from the current justified epoch to say 2 days in the future. And the interchange format, if you exported that history, it's going to be a whole bunch of attestations and then a big gap. And the rules say that you're allowed to keep signing messages inside the big gap because you're not less than the minimum, so long as they're not slashable with anything else inside that set. And this is exactly what we would have needed to escape the catastrophe in this case, because affected users could have exported their database to the interchange format, imported it into another client that wasn't affected by the clock sync bug, gone about their business of signing messages as usual. And then when the bug was resolved, they could export their database and safely go back to Prysm if they wanted. And there's a small caveat here in that because of, if you sign a really, really big attestation that spans, say, 2 days, you're setting yourself up to be surrounded by that attestation, basically. So you'll be able to make a few more attestations until the source epoch that's agreed upon by the consensus, like until the justified epoch moves forward. So once that justification happens, say you've made an attestation starting at epoch 5 and ending at epoch 1000, as soon as the justified epoch moves to epoch 6 and you're expected to vote from 6 to 7 or 6 to 8 or some small attestation inside there, that attestation is surrounded by your incorrect attestation, so you can no longer make it. But in the case of blocks, you can keep signing blocks through the whole period. And then once you catch up to where your faulty attestation in the far future was, then you can resume signing again as normal. And the slashing protection databases of all the clients will handle that. And the interchange format handles that as well. So
is the idea that like the person that submitted the faulty future or whatever, they wouldn't be able to do any validation until the blocks caught up?
Yeah, so they can keep using the chain, and they can keep making blocks, and they can keep making attestations for like a little while. Probably, if the rest of the network stays online, probably only one epoch until the justified checkpoint moves, because it moves every epoch by one. So yeah, they wouldn't be able to attest, but just being able to make blocks is useful because in several periods of non-finality, we've had real problems with getting participation on testnets. This is, we've had problems with getting participation high enough, partly because there aren't enough block proposers actually making blocks. So just not losing, I think Prysm nodes make up a huge amount of the network. So if they were to go offline, we'd lose maybe 50%, 40% of our block proposals. And that's block space that other voters can't include their attestations in. So even just being online and making blocks is better than being completely offline. Yeah.
And then
Okay.
one other question: do you mind explaining what an attestation is?
Yeah. Okay. So yeah, that's probably that. I probably should put that in the background. So an attestation is a message that a validator makes in order to vote on one specific version of the chain. And it's how Eth2 comes to consensus. So when you have attestations from a sufficient number of validators, it turns out to be 2/3 of validators by balance, then you're able to say that the chain agrees upon a block. And then that block becomes, first of all, justified. And then later, when another 2/3 of validators have voted from that block to another epoch, then it becomes finalized. And once a block is finalized, there's this cryptoeconomic guarantee that that block can't revert unless more than 1/3 of the validators by balance perform a slashable offense and get slashed. So it's how we do. Yeah, it's how we do consensus without proof of work. That's the whole, that's the core of the proof of stake protocol. Yeah.
Michael, I have a question for you as
Yes.
well. I was thinking about justification finalization and how to explain it intuitively. And this is what I have right now, but I think it might be wrong, and I just want to get your feedback on it if possible.
Yeah,
so
sure.
how I think of it intuitively is justification is you have a checkpoint that 2/3 of validators have essentially agreed is the truth at that time. And then how I would think about finalization is, so a checkpoint first has to be justified. So 2/3 of validators have agreed this is the sort of provisional truth at the time. Finalization means 2/3 then are able to see that 2/3 have agreed, and it's sort of like a double agreement because they've all seen each other agreeing, and then when that's done, that is what we call finalized. Right? It's very hard to revert that history. Is that more or less?
That's exactly right, and that's exactly how a bunch of Byzantine fault-tolerant protocols were designed as early as the 1990s. So this thing of having one round of messages, and then everyone sees that round of messages, and then it's locked in. That's a very common pattern in consensus protocols. So yeah, I'd say it's a good intuition.
Okay, great. Didn't make a fool of myself.
Cool. Does anyone else have any questions?
Yeah, I'm still a newbie too, but I'm wondering. So every client has to know and be aware of all of the other clients, so they can know when 2/3 has been met. I'm just, or is that being done by signing, public signing, and you see the amount of signing in the mempool, or anyway? I'm just not clear.
Yeah. So no, that's a fair enough question. So the attestations that I was talking about, those messages where everyone's voting, there's a lot of those, right? We have 70,000, 80,000 validators on mainnet. So you need thousands and thousands of votes. The key innovation, I would say, of Eth2 is that we have a way of combining these votes into very succinct messages via BLS aggregate signatures.
Oh, okay.
So if you cut the validators up into committees in each slot, and each committee has maybe 100 or so validators. If all those validators agree on what the chain is, they all sign the same message. And when they sign that message, BLS allows us to add their signatures together into one message that's like 96, 128 bytes, the order of that size. So you can have on-chain blocks that are only a couple of 100 kilobytes maybe, but that include votes from thousands and thousands of validators. And that's thanks to the magic of a BLS signature.
Which let me, I think BLS is a little bit complicated, but like essentially with BLS, it's you add up everything you're trying to validate. If you sum up all of them, then like it has to be true. Like if you, sorry, or feel free to jump in. I'm trying to explain this, but it essentially is normally for normal encryption, you have to encrypt each signature and validate each signature. And then for BLS, you sum up the signatures or everything, and you can validate whether or not all of those are were properly validated. Is that about right?
Without having to talk to all of them.
Yeah, exactly. That's exactly right. So you never need to communicate with 70,000 nodes. The network is cut up into little into little portions called subnets, and in each subnet, everyone's voting and they send their votes to each other, and then that subnet sends its aggregated vote, which is what Alida was saying. You add all the votes together, and you get just one message that can be checked quickly, and then the rest of the chain is just validating like maybe 32 times 4, like maybe 128 of these aggregate messages each epoch. Maybe a bit more. But,
thanks for that newbie card.
Yeah, that's good. I'm happy to answer more general F2 questions as well, because I realize that it's something that is very familiar to Eth2 devs, but to other Ethereans, can be a bit foreign. Yeah. Okay, cool. I'm trying to remember whether I have any more slides. Let's see. Okay. Do we want to move on to the EIP finalization. I think I've got one more slide. Yeah, so our EIP has been implemented in all 4 of the major clients running on mainnet. Lighthouse and Teku have supported it for a while, and it's in the latest stable release. And Prysm, I think, are making a release this week that will include it. I think that's their V1.2 release, if you're looking out for that. And I think Nimbus also have support coming in their next release too. And there's a set of standardized tests that we've written that allow clients to check their conformance to the spec. And I think all the clients are now passing those standardized tests. And then, as well as Eth2 clients, we also have this this remote signer from Consensus called Web3 Signer. And this is a process that you run on multiple machines, or you run with a really big backend, and you allow lots of validators to connect to it and make signatures, and then it keeps track of all those signatures and makes sure that you don't get slashed. So you can also import and export your signing history to and from Web3 Signer. So yeah, I think that the EIP could be finalized pretty soon in the next few months. I'd like to see it stable and sort of being used on mainnet for a little while before we press the button on fixing it in stone. But yeah, it's done, and I think it's pretty much ready to go. Cool.
So can I actually hop in? I have a question. It seems like the implementation is reliant on the clients. Is there an issue of if a client makes a mistake? And is there in that?
Yes. So if there were a bug in a client implementing the interchange format, so probably the main thing that would happen is not exporting some messages for some reason, or failing to import some messages for some other reason, then that could be quite dangerous. And that's why we've worked quite hard to nail down all the corner cases in a standard testing format. And these are kind of already corner cases of corner cases, because the format is really only applicable in quite catastrophic scenarios. Like, to be clear, you could, a lot of people before this interchange format existed, if they were to switch clients or switch machines, they just wouldn't bring the slashing protection database at all. And normally, if the network is running well, that's kind of fine, because time is progressing forward. The messages you've signed in the past have almost no bearing on the messages that you're about to sign. And it's only really in the case of sort of deep reorgs, or really quick switches from one client to another, or time sync issues where you've signed things in the future, that you run into trouble. But yes, if there were a bug in a client's import or export functionality, and at the same time they happen to get unlucky and hit some turbulent network conditions, then people could end up getting slashed. That's the ultimate consequence.
So then to just like kind of repeat what you said, you're saying that we're trying to prevent that in clients by building out, or you all built out like really thorough test cases to verify that all clients were compatible?
Yeah. The main way that it really gets prevented is by the slashing protection databases of each client. So the interchange format is really just a way for them to transfer that knowledge between different clients. The main heavy lifting of preventing slashing is in each client's slashing protection. So if you just use say Teku, and you never switch away from Teku, you never change machines, you've just got Teku set up and it's running and it's stable, you are protected from slashing by Teku's slashing protection database. And even if the interchange format never existed, that would still be the case. So it's only really when you want to move clients that the interchange becomes relevant.
Right. To add to what Michael's saying, it's important to bear in mind that this doesn't prevent you from, it doesn't cover every case where you could possibly slash stuff, right? I mean, one thing it doesn't cover is if you are running your validator on a machine, and then you decide to switch machines, but you leave your validator running on the original machine, right? Because and you forget about it, because by definition you haven't exported that database, you haven't switched your validator off. So it doesn't cover every possible case as well. I think that's important to remember, to not be complacent that just because this exists, that there's no way you can get slashed. You can still make errors. And this is more about, I mean, this covers the cases that Michael has outlined basically, but not every possible case.
Yeah, actually, I'm so glad you emphasized that. That's totally true.
And is there like any place to see like where you think slashes could occur, so that way like validators could have an idea for what to avoid?
Yeah, so that when you sign up to become a validator, the Eth Launchpad tries to make it quite clear that you should. The main one is just never run the same keys on 2 different machines at the same time. That's pretty much the only case that's not covered by our slashing protections. And the reason for that is that it's hard for clients on different machines to even know that the other one exists. And there is some work being done in this space to make that safer, but yeah, that's the main one. Like if we can send any message, it's just don't run the same keys at the same time. Cool.
I may have one question. I remember the mention of the use of smarter database schema for slashing protection in Prysm in the last implementer's call. Because this proposal is basically a database interchange format, does any of you have thoughts on how compatible that schema would be for the implementation of 3076?
So you mean the Prysm team's new database schema?
I was referring to
yeah,
that.
I'm not familiar with what they're doing internally, but I'm quite sure that it would map closely onto the format because I implemented Lighthouse's slashing protection, so I'm more familiar with that. The export process is basically take the entire database as it exists, transform it slightly, just like by mapping a few fields, and then dump it into the interchange format. And I suspect that it's similar for Prysm.
As in one of your slides, you mentioned about double voting, and I believe there was recent validator slashing that happened yesterday. I'm not sure. That is one of the biggest on the mainnet, over 60 validators in 2 hours. So I was wondering if there is complete implementation of this proposal in Prysm, would that have been avoided? Do you think that complete implementation could have prevented it in any way?
Yeah, no, it actually wouldn't have. I think for each of the slashings that have occurred on mainnet, including the one yesterday, they have misconfigured their validators, or they've written custom software to try and do fast failovers. And in that case, they're not protected by their internal slashing protection database, nor are they protected by an interchange format. So most of the slashings have actually been slashing pools writing custom software and ignoring or disabling their slashing protection databases that come with the clients. So even though using a client is safe, using a custom setup that hasn't been tested thoroughly is probably not safe. Or just running two nodes at the same time in parallel, which you can do accidentally as a result of sort of failover infrastructure. If you have some automatic script that spins up a new version of your validator as soon as your old one goes offline, you're basically asking for trouble, because if there's any bug in that, you end up with both of them running at the same time, and then you're slashed and no database protects you in that case.
Yeah, I think that makes sense. So
it's a little bit unfortunate that that's the state of it at the moment. And I think there's this, to talk about another slashing protection strategy, there's this thing called doppelganger detection that we might do in the future. And I think Nimbus may have it already, but when a client starts up, it can listen for messages from the same keys that it's using and see if there are any messages propagating on the network already. And if there are, then it refuses to start and doesn't sign any messages. But this is still something that could be opted out of by people, in which case they're liable to shooting themselves in the foot again.
okay, so I have a couple of suggestions for the EIP status. I see that the present EIP that is in the draft status, but recently the process improvement group, they have introduced one more status that is called review, that is in between draft and the last call. So now that the proposal is already implemented in major clients, in my opinion, the best would be the review. The best status for the moment would be review. But my question, however, is for the readiness for the last call. Correct me if I'm mistaken. My understanding is this proposal is not that it would be undergoing hard work 1, HF1 that was mentioned in the last implementers call, and expected to be final sooner than that. Do you have any thoughts, like how soon do you expect this to be ready to move on?
Yeah, I'd say we could move as fast as our schedules allow us, I guess. The main reason that I haven't tried bumping this to review is that I haven't had time. I'd say I'd like to see it run on mainnet, and I'd like to try out all the other implementations of the format before I'm happy to bump it to final call. So I'd say the soonest it would happen would be a couple of months, maybe 1 or 2.
That sounds good. It would be great if one of you can, create a pull request to change the status. Also, I'm happy to share that the CAT holders are currently helping out with getting proposals in appropriate status. Like we have done it for so many EIPs. I understand that there are some bandwidth issues with the implementers devs. So we'll be happy to create a pull request and send it for your approval if it doesn't get, changed request status very soon.
Yeah, no, actually, thank you for the heads up. I think I can probably, we can put through a change today or soon.
All right. So we have hit the time, but if anyone has any last comment or question.
Sure, sorry about that. I just wanted to jump in and ask you about security. So is it a concern if, for example, there were some sort of way to get the clients to begin slashing, right, or to cause problems, like similar to the Madasha chain testnet? Would that open an avenue for, like, a nefarious actor to take control of the consensus on the chain?
Okay, so you're saying if enough honest validators were slashed?
Yeah, because of some bug or something that happened.
Yeah, so I think if you were able to find like an RPC call that caused random nodes to get slashed over the internet, like that would be a critical bug in Eth2. I think the chance of that happening is quite low. But yeah,
like the algorithm seems very simple, which I would guess is very secure, but
yeah, so if you could slash a large number of honest validators, then you would have a better chance of performing a hostile takeover. But as soon as you did perform a hostile takeover, you yourself would get slashed by the remaining honest validators. So yeah, I don't really know what else to say. I think that, yeah, the architecture of the clients is the main thing that protects against that, I would say, in that the slashing protection database is often completely separate from the network facing code or things like this. So yeah.
If you were to like say that some event were to happen and you were to revert the chain, similar, I mean, it's happened in Ethereum before, right? Where we go back, like, would the slashed nodes be restored, or is that like a permanent change?
That would be a big, like, social commitment to revert the chain. I'm not sure if we would do that if there were a mass slashing. I think I think there'd be quite a lot of momentum to just keep the chain running, because at the moment the slashing penalties are actually lower than they will be eventually, or slightly lower. So getting slashed, okay, no, getting slashed en masse is still bad. If you get the slashing severity increases with the more people that are slashed alongside you. So if heaps of people get, like if half the validators get slashed at once, then they lose almost their whole balance. Actually, more than a third. If more than a third gets slashed at once, they lose their whole balance. So yeah.
So it would be a very difficult thing that would happen for the chain.
Yeah, it would be bad. Yeah. But
where does that ETH go, by the way? When you get slashed?
When you get slashed, most of it gets burnt, and some of it gets paid to the person to the validator who slashed you, as a reward for as an incentive.
So that seems like a really high incentive to be a nefarious actor, isn't it? To be slashed 1/3 of the chain, but yeah.
Yeah, so slashing other people is always going to be quite profitable if you can do it. So that would be a reasonable attack that didn't get you yourself slashed. If you could trick clients into voting on something and then voting on something slashable with respect to that, if you're exploiting a bug in the slashing protection database of one client, for example, that's probably the most feasible sort of attack. And you would profit a little bit from that, and the other validators would lose quite a lot.
An important thing to note about that type of attack is that to include those messages, you actually need to be a proposer as well. And so even if you can conduct such an attack, you're not necessarily going to be the one to profit from it if those messages were broadcasted on the network. Obviously, if you go and like hand pick them, then it can, there's potential attack vector there. But yeah, just something to note. And hello.
Hi, Danny.
Hi, Danny. Good to have you here as backup.
Yeah, nice to have you here, Danny. So if you would not mind, can we go ahead with a couple of more questions that we have saved for you?
Yeah, absolutely.
So like we had this wonderful session yesterday about the research work that had been done by the Eth2 implementers and R&D team. First of all, I would like to congratulate for that. And I'm curious to know a little bit more about the hard fork 1 and the following upgrades those are coming on, the timeline basically. My question is, assuming the first upgrade hard fork 1 by the end of Q2, is it fair to expect the Eth1, Eth2 merged by the end of 2021? And if so, in your opinion, what would be the proposals that features that would be needed from the Eth1 team to be, let's say by the end of Q3 for Eth1, Eth2 to be merged in November, December?
Right. So I definitely, I think we're on pace to do a hard fork 1. That's a code name. I guess it'll get a real name at some point in the summer. So end of Q2, beginning of Q3. There's some work to do. There's a kind of a working document with some of the features that we've definitely kind of narrowed in on, which are some minor modifications and fixes, some cleanups to the way state is managed, and a nice to have like extension of a feature that makes light clients very easy. This hard fork also serves as kind of a warm-up hard fork in the sense that these ETH2 clients, these proof of stake clients, this beacon chain hasn't gone through an upgrade cycle yet. And so better to do it in relative isolation before we attempt a larger one with sharding or the merge. From there, kind of as that hard fork is put in place, there's gonna be the side work going on continuing to prototype and refine some of the early specifications on sharding and the merge. And hopefully by the time hard fork 1 goes out, we'll have good information on which of those two should be prioritized. If both are ready to go, it's going to be a little bit more of a decision to be made. But if one is much more technically reasonable and feasible at the time, then maybe the decision will be easy from a technical standpoint. I'm personally think that for these two major upgrades that we want to do for the beacon chain, sharding, and the merge, that by the end of this year, we should have production grade and will have production grade test nets, and are setting a date for the beginning of next year. And so maybe a little bit slower than the expectation of actually launching at the end of this year. But I think that we can be in a good place to have all the pieces in place to put it together for the beginning of next year. So if it were to be the merge, as you asked, there's obviously a lot of cross collaboration between kind of the ETH2 sphere and the ETH1 sphere, the unification of Ethereum into this new proof of stake consensus mechanism. And in terms of I guess in terms of how it goes for the things we talk about on this call, like EIPs and specs, there's this we have to figure out the right dance between where things are specified. Because I mean, ETH1 is largely specified kind of in the yellow paper, kind of in the smattering of EIPs that have gone into the network, and ultimately via the code that is run. And in ETH2, which it represents this like proof of stake layer, it's largely done in this independent spec repo, and then it's been kind of loosely tied into the EIPs, as we discussed on one of the calls about a month ago, maybe 2 months ago. And so we need to find where these specs meet, and I would imagine they meet in an EIP, and kind of point to where the specs, because the ETH2 specs would call into validations and verifications that are in ETH1, which are kind of implicit in the EIPs in the yellow paper. And so we kind of have to define this interface and show where they all link together. There's definitely some thought and work to do, and we should probably be proactive with some of the EIP editors to come up with a good strategy here. And then in terms of work, there's a ton of work to do on ETH2 side and ETH1 side. We're beginning to do some work on Hive, which is kind of a continuous integration work that does like load and sanity testing of ETH1 clients, I think on a nightly build, maybe weekly. And Proto on our team is doing some work to modularize that so ETH2 clients can live in there. And then from there, we'll do Hive tests that actually simulate this merge where you hot swap proof of work, proof of stake. And then as part of the workshop on the ETH1 client side, it's really a matter of taking the brain of the ETH1 client, which traditionally was a small proof of work module, and instead replacing it with the ETH2 client as the brain and the driver of consensus. And so it's a little bit of an art of subtraction, and which components become ultimately subtracted out of an ETH1 client and are deferred to this ETH2 consensus. And then there's a lot of little details, especially some of the fun stuff on like state sync and block sync that came up at the end of our call that Peter brought up. I think in general, this kind of marriage of the two clients is pretty straightforward, but then on some of the edges, like state sync, it's on the edge, but it's a big one. There's some work to do in thought and specking, prototyping, and all that kind of stuff. So there's a lot to do, but it's definitely scoped, like we know what we are attempting to do, and the bones and even some base specs are in place. And even I actually saw somebody not on any of the teams that have been working on this, but an independent team, a different blockchain, took the Teku Geth merge prototype and actually has a live testnet today with it, which is kind of cool. It's kind of funny. So anyway, that was a long-winded response, but there's a lot to do. And in terms of the context for this call, the EIPs, I think, there was definitely a question of where does ETH2 fit into the EIP process? And that question, I think, becomes exacerbated even more so when you have the unification of the two, kind of how are these things linked and combined? And it'll be a fun one to figure out in the coming months.
Definitely. So I just have one last question about this testnet thing, like you mentioned about Hive. So I'm curious to know about the future of Pyrmont. Do we see that for HF1, or do we have something else replacing it sooner?
A replacement for Hive, was that the question?
Replacement for Pyrmont.
Oh, right. Okay, so Pyrmont is actually, and Michael would know how to say that better than I, but because that's a place in Australia, it serves our purposes today. We've talked a little bit about how we might modify it to make it have a little bit higher quality of service. Essentially right now, a rogue actor could get a bunch of Gorley ETH and kind of like they couldn't take the network down, but they can make it not finalized and make it kind of annoying for people. And so it's not super resistant to that. Attacker, if you're listening, you know, there's an attack, but for now, it does serve quality of service. We might end up, as we're approaching a hard fork 1, consider how to make a more sustainable version of Pyrmont and coordinate some of these hard forks. But if Pyrmont continues to serve our purposes, I would imagine we'll do something like we see in the ETH1 dev cycle, where we take it, we deploy at a certain slot number rather than block number. We would kind of, this hard fork 1 would be upgraded on Pyrmont. We'd observe it for a while and then bring it to mainnet. And way before that, we would do that kind of in transient test nets of our own and do some load testing and some corner cases and fuzzing and all sorts of stuff before we started messing with Pyrmont. But so Pyrmont's still a bit of a question mark. I think because it works, no one's really eager to mess with it because there's tons of other stuff to do. But it might get overhauled at some point.
Thank you so much for your answer. And thank you everyone for being patient and taking questions other than the proposal itself. So
yeah, sorry it was so late, but I appreciate y'all having me. And I'm sure Michael and Sasha did a great job.
Indeed.
Thank you.
The presentation was really wonderful. I really appreciate you all taking out time and sharing this information. It was great chatting. Thanks to the Ethereum cat herders and the Attestation Reddit community for collecting questions and making this session even more knowledgeable. This proposal provides the flexibility to user to switch between the clients without risking slashing. Hopefully, with this episode out, people wanting to experiment with running nodes of different clients will be confident, and eventually we can accomplish the diversity of clients, something that we have been trying to achieve in Ethereum chain for a while. On that note, for our YouTube viewers, the presentation and other resources for this proposal are available in the description box. If you have any question that couldn't be answered today, you may leave a comment or ask the authors. We are going to provide their handle, Twitter and GitHub handle in the description section. If you like this episode, do hit like. Let us know which EIP would you like to see in future episodes. Your feedback is very important to us to be able to bring more informative episodes. Thank you very much, you all, for joining us today.
Perfect. Thank you for having us.
Thank you.
Everyone.